Okay, we're back and we are still on note 2.3b through 2.4, Roman numeral 2. This time we're starting with problem number 3. Number 3 says use the remainder theorem. Okay, you may not recall what the remainder theorem is from Algebra 2, but we're going to discover what that means as we go through 3a through d. What I'd like for you to do first is complete 3a, 3b, 3c, and 3d. So pause the screencast, complete number 3, a through d, and then turn the screencast back on. Okay, so what was the remainder for x cubed minus 7x minus 6 when we divided by x plus 2? So if we look back up at number 2, we see that the remainder was 0. And if you said 0, you would be correct. Then I ask you to evaluate f of 2. F of negative 2, that is. Okay, so let's see. When we plug negative 2 into our function, we should have negative 2, oops, sorry about that, negative 2 cubed minus 7 times negative 2 minus 6. Negative 2 cubed is negative 8. Negative 7 times negative 2 is plus 14 minus 6, which is 0. So what did you notice about your answer to 3a and 3b? I noticed that the remainder equals 0, and when I plugged in negative 2, that was also 0. So let me say that again. When we divided the polynomial by x plus 2, you used synthetic division. So you divided by negative 2, and you came out with a remainder of 0. Then you plugged negative 2 into the polynomial, and you also came out with a value of 0. So my question in D is, do you think that x plus 2 is a factor of this polynomial? And then why or why not? If you said yes, you would be correct. Why is x plus 2 a factor? Because the remainder equals 0, or because f of negative 2 was equal to 0. Now remember, negative 2 represented c up here in the x plus 2. Remember, that was x minus c. So we could say that when the remainder is 0, or when f of c equals 0, then this binomial is a factor of the polynomial. All right, so why is that important? That's important because you won't always be able to factor a polynomial using the traditional methods that we've learned thus far. X cubed minus 7x minus 6 is not a quadratic. You can't factor that using the reverse of FOIL. You have to be able to find one factor and then go from there. So let's see. If x plus 2 is a factor of this polynomial, then find any additional factors. This should have said, this was a misprint. So if x plus 2 is a factor of x cubed minus 7x minus 6, I'd like you to find any additional factors. So how do we find those additional factors? Okay, so number 1, we have to synthetically divide by x plus 2, which we've already done. Okay, well, what was the polynomial that we obtained when we synthetically divided? It was x squared minus 2x minus 3. So transfer that down to e. X squared minus 2x minus 3. That's right. Okay. And then I ask you to find any additional factors. So we synthetically divided. Here's the quadratic that we obtained. How would we find additional factors from x squared minus 2x minus 3? Well, we would factor it. So let's see if that factors. X squared factors into x times x. Negative 3 will factor into 3 times 1. We want it to add to a negative and multiply to a positive. So now we have 2 additional factors for our polynomial. Question F asks, what is the final factored form of x cubed minus 7x minus 6? The final factored form is x plus 2. Remember, we've already proven that x plus 2 is a factor. And then we factored the quadratic that we obtained from our division, times x minus 3 times x plus 1. So G asks, what are the zeros of f of x equals x cubed minus 7x minus 6? Remember, we've discussed in our last 2 classes that zeros are also x-intercepts, which are also the values of x when y equals 0. So remember, this would all equal 0. It's the factored form. The first factor gives us x equals negative 2. The second factor gives us x equals 3. And the third factor gives us x equals negative 1. Do you notice anything about the degree of the polynomial compared to the number of zeros? The degree is 3, so we have 3 zeros. That completes your review of long division, synthetic division, the remainder theorem, and using that remainder theorem to prove that a factor, to prove that what you're dividing by is a factor of a polynomial, and to use that to find additional factors of the polynomial. I'm going to stop this screencast, and I'll make Roman numeral 3 a separate screencast.